So my name is Joe Stein. Nice to meet everybody. I'm going to be speaking to you about real-time streaming and data pipelines with Apache Kafka. So when someone says real-time streaming to me, this is kind of the picture that pops up into my head, right? I kind of see some public interface, some set of application or applications, and ultimately what they're doing is trying to work with different subsystems within a system, right? There may be very discrete or systematic ways that you're trying to link different data that's flowing within your infrastructure. You may have some persistent high availability cache sitting underneath it. And ultimately, when we're talking real time, at least for the sake of our discussion, let's just say if it's under 10 seconds, it's real time, okay? When I start thinking about data pipelines, I start thinking about components, right? So let's say you unscrew that subsystem and you look at the subsystem that's sitting underneath. Ultimately, you have little components that are sitting inside, right? The component is emitting data as an output, and it's an input to another component. And real-time streaming with data pipelines is that, not just within a subsystem, but also across subsystems. And you want to do that with very low latency. So if you start to zoom out a little bit, right, you screw the little subsystem back together and you zoom out and you start to look at the subsystems and you look at what may be certain people's infrastructures, right? You have a storm system. You may have some Cassandra in there for doing high availability caching. You may have Hadoop for some type of ad hoc reporting. You have a whole bunch of domain systems, right, specifically to your business. But you still have those applications that are essentially still trying to write data and events of what's happening. And based on the events that are happening, they're still trying to get something out after that. And this is really where Apache Kafka comes in. If you zoom out even further, right, you may even span across availability boundaries. Right? I don't want to call them zones or data centers, but just availability boundaries. And you start to see where having a central system to basically handle these different data pipelines, maybe makes sense. So before we get started, I didn't really know where everyone was when it came to Kafka. Maybe it's zero in that you never even heard of it before and you saw something on a meetup and it looked interesting and you wanted to learn, all the way to, hey, you're running it in production right now and you can't wait for 0.81 and 0.9 and everything else. So what I did is try to base the presentation for everybody. If you go and you can check out the sample code for this presentation is up on GitHub. All the Kafka code is open source, so you can go and download it and look at it. The documentation is fantastic, right? It's written in English for humans. If you want to know what Kafka is doing, look at the code, because that is written for the computer. Documentation, humans, code, computer. But between the two of them, you can really get everything that you need to out of it. There's a wiki. A whole bunch of good stuff on the wiki as wikis go. There's a whole area of presentations and papers. So if you've seen any Kafka presentations or you haven't and this is going to be your first one, still go check these out, because a lot of stuff is out there already and I'm not going to really rehash or cover too much that's already been spoken about, and try to keep the community moving forward, which all of you are now part of the Kafka community, so welcome. And then there's some tools that you are going to want to take a look at, the replication tools. I'm in progress starting to document some of the other tools that are out there. But for right now, you're just going to have to kind of go and look at the source code. And there's good documentation inside of the code, good comments to what all the different arguments are and how you run them. But you kind of have to go to the class files right now to do that. Oh, thanks. OK, so Apache Kafka, it's fast. What I mean by fast is your bottleneck is going to be your network. Right? Kafka was built in such a way that the brokers are basically taking data off of the socket and appending it directly on disk. Okay? Your bottleneck is your network. All right? There are a lot of other benefits and features that are in Kafka to make it fast, such as batching and compression. And I could talk for 30 minutes about that, but let's just take it that it's fast. It's Kafka scalable, right? So Kafka allows you to actually have multiple, dozens, hundreds even, different consumers reading off of the same stream at the same time. Other systems that we'll call messaging systems don't act like a commit log. Right? Kafka is a commit log, just the same way that you have a journal or a commit log in your database. think of Kafka as the commit log for your data pipelines. Okay, it's the commit log for your infrastructure. It tracks everything that's happening and then allows everyone to read off of the streams without getting in the way of who else is reading from it. So everyone in this room could be reading off of a Kafka stream, and the broker doesn't really care. It's happy to send you data as long as your network is fast enough to push all that data across. Kafka is durable now, so in the 0.8.0 release, there is intra-cluster replication, and we'll talk a little bit about your balance between consistency and availability and how you can kind of go back and forth depending on what data you have. Maybe some of that data needs to be more consistent versus more available, but it's durable now. We'll talk about that a little bit. And Kafka is distributed by design, right? The producers and the consumers are completely decoupled from each other. And that makes for some very good design patterns that we can introduce. OK, so when I first started thinking about this talk and sitting down, I was like, oh my goodness, I haven't actually sat down and from scratch wrote something, producer and consumer. And I looked and I was like, wow, how do people do this, right? Like, how do you come in and just start from nowhere? So what I did was I spent a couple days and I put together a kind of an example project so that you could sit down and within 5 minutes be completely up and running and developing producers and consumers in Kafka. So I don't know if anyone's ever used Vagrant before, but Vagrant is basically a way to script virtual machines. It's awesome, OK? You say what operating system you want. You say after boot what should be installed on the operating system. Really, really handy tool. VirtualBox is just a virtual machine that can run a thread or two for our development purposes on a local machine. That's fine. So you got to get those two installed. But once that's installed, you clone the repo, go into the directory, and you type Vagrant up. And that's it. When Vagrant up is done running, you'll have a Zookeeper virtual machine running, and you'll have a broker virtual machine running. And the broker will be configured with Zookeeper. And at that point, you could just run the SBT tests. So you just run the test cases inside of the project, and it will go and run against the broker that is locally running on your machine. So if you've never used Kafka or you're going to get started with Kafka, I would say start here. Really just spin up everything on your machine and start going through the sample code, which we're going to start doing a little bit for this talk. All right, so if you use Maven, here's how you get started with Maven. Here's a POM that you would use. POM still needs a little bit of work. Kafka 1160 is still open to get rid of this little exclusion clause. But besides that, you're good to go. If you have some other library that's already excluding these libraries, then you don't have to do this. But if you don't, then you do. So here's your POM file to kind of get going. I also recommend to use the Kafka 210, Scala 210 version for your dependencies. If you're not using any Scala version, then go with this one. It's the latest. If you're still on an older version with Scala, OK, good for you. It's all good. We'll talk about that some other time. In SBT, it's just as simple. If you don't, you have to throw in this intransitive. It's kind of the same thing. Or like for me, I pull in so many different jar files that it's already excluded. I don't have that issue. So Kafka 1160. If anyone else is, does SBT in their sleep and wants to contribute, I'm sure it's a simple change in that build.scala file. If nobody else gets to it by 0.8.1 release, then I will spend a Saturday night and fix it, promise. But hopefully someone else can contribute, and I could take a look and commit it back to the project. OK, so let's talk a little bit about Apache Kafka. Producers, consumers, and brokers. Ultimately, everything is going to fall into one of those three categories. When we talk about producers, we're going to start talking about topics. Right? So topics are kind of where you're putting your group of information. And your group of information is really dictated by everything else that we're about to talk about for the next 45 minutes or so. So I'm not going to get too much into it with producers. But your topic name could be anything. It could be the hour of a day, which is great, especially if you're trying to do batch reconciliation, because if a server goes down for 20 minutes and it comes up 2 hours later, when it pushes its data back into the commit log, it'll do it at the specific time and hour of a day. You can produce to multiple topics as well. So there's a lot of different ways that you can use topics in the design patterns of your system, and we'll talk a little bit about that. We're going to talk about brokers and kind of the role that brokers play with producers now in 0.8 and how they control things like load balancing. We're going to talk about sync producers and async producers, and I'm going to introduce everyone to the async sync producer, right? So this is a Akka producer that wraps around your existing producer that gives you control between consistency and availability when you're producing data to Kafka. So we'll talk a little bit about that. On the consumer side, we're going to talk a little bit more about topics because topics are really a way of grouping partitions. So we'll talk about partitions, what partitions mean, how many do you need, really how to figure out how many you need, so kind of like a little playbook to understand kind of what you actually need to set things up. We're going to talk about read from start and read from where last left off, right? So when you're reading the stream, you tell the broker where in the stream you want to read from. So that could be the last place that was left off or at the beginning. And there's been a lot of talk in the mailing list as well between, well, you know, I want a durable system, and after I read something for the stream, I've got to make sure that it's been committed, and I can't do that with the high-level consumer. I'm like, oh my God, how do I do that? Right? So I'm going to talk to you about how you can do that with the high-level consumer and not use the low-level consumer API. So if you're looking for that kind of stuff, definitely stay tuned. We'll get to that. But I'll also kind of point you to the low-level API. It's there. It's, you know, go for it. I personally like the high-level consumer. There's a lot of good stuff that you can do with it and work around. For all the benefits that it has, the trade-offs in using the low-level API has really got to be, you know, powerful. And then we're going to talk about brokers. We'll talk a little bit more about partitions and kind of round out the whole what is a partition. We'll talk about load balancing producers, load balancing consumers. We'll talk about in-sync replica sets and what all that means, and then kind of end the talk with client APIs and how else you can access Kafka without just using Scala, because all my examples are in Scala. OK, so let's start with producers, right? So again, topics. Producer sends data to topics, right? Producers also have to know about brokers, right? A broker is essentially your central point of your commit log. Sync producers, async producers, and that async sync Akka producer. All right, so setting up producers, 2 lines of code, pretty simple, right? You basically say which topic you want this to produce to and which brokers you're trying to send the data to, right? If you have a cluster of 3 brokers, then you're going to have 3 brokers in the list here. And then you go ahead and send the message. And that's it, right? Kafka supports bytes. Really, it wants bytes. You've got to give it bytes. If you want to send something that's not bytes, that's OK. Just turn it into bytes, right? And some people use topics to actually figure out, you know, different serializations, right? So which topic has what serialization format, or even dynamic serializations. I'll talk a little bit of that more when we get to consumers. Under the hood, the Kafka producer class that I created, this is doing a lot of the kind of configuration heavy lifting for you. Kafka is a lot about configuration, right? So if you kind of want to pull all the levers and everything else, you've got to kind of set the configurations right. So in my constructor, you know, before my 1 line of code, topic and broker was dynamic. Here I'm saying, let's make it a synchronous producer. So let's talk about synchronous producer since I've decided to default it to that. So a synchronous producer is basically when you, as the producer, you're going to wait for the broker to tell you whether or not the data has been saved. And you have a lot of flexibility around that. You can say to the broker, OK, for this topic, the replication factor is 3. You have 3 brokers. But I don't want to have a success unless 2 of the replicas already wrote the data. OK? And if 2 of the brokers are down and you can't write the data to 2 brokers, you're going to get an error. You're going to get an exception, right? That's choosing consistency, right? You want to now you have to deal with that exception, right? But that's the trade-off that you're making to have durability is that, right, you now have to deal with not being able to write to the commit log. Or you accept that I want to write to the commit log. There are 3 brokers. 1 of them is down. OK, I've written to 2 of them. Yay, my data's in 2 places. Fantastic. Even better if it's on 2 separate racks, right? So the synchronous producer really allows you to have a very tight relationship with the broker. Now, it also is synchronous, OK? If you're going to do 10,000 connections into the broker, you're synchronously going to do 10,000 connections to the broker. So you're now starting to trade off your internal infrastructure and communication in the infrastructure for, you know, this synchronicity. Well, that's where the async producer comes in, and these next few parameters. So compression is pretty obvious. It compresses the data, right? But batch size, OK? Batch size is a really important parameter. When you're sending something asynchronous, okay, you just set synchronously to false, okay? What this producer will do is take all of your messages, okay? It'll respond to the producer right away. That one line of code that's saying send message, it'll just respond right away. So within 200 microseconds, you've already produced something to the queue. And it'll put it on its own queue, and it'll start filling up the queue until it hits the batch size. Here, 200, right? And then once it hits 200, or it's been 5 seconds, it will then take all of that and in one connection and one transmission, send that over to the broker. So you can see if you're in an environment where you've got more than one message per second, maybe 2 or 3 per second, maybe 1,000 per second, right? This becomes very, very exciting because not only can you batch messages, right, but you can have you can reduce the herd effect that's going to come with everyone trying to talk with everyone else inside of your network, right? Asynchronous is obviously going to be faster than synchronous, and you may want to decide that for certain type of messages that you're producing, asynchronous is more than good enough. One good example. So Kafka comes with a log4j appender. So who's ever used log4j before? All right, come on. Yeah, obviously, right? All right. So Kafka has a producer that's a log4j appender producer. So if you're already doing log4j, then tomorrow you can start producing all of that data to Kafka. Now, great, perfect use case for putting that asynchronous, right? If you lose 10 milliseconds worth of data, not a big deal. If you learn 10 seconds worth of data, yep, probably not a big deal either, right? If you're all of a sudden putting in bookings for a hotel room, let's say, right? You know what? You can't lose data, right? Someone booked a hotel room. You don't want to be the guy or the girl that is responsible when someone went to the hotel and said, oh, I had a reservation. I'm sorry, Mr. Stein, but the hotel's all booked up. You got to go somewhere. You don't want to do that, right? So it's different information and different messages needs to have different levels of consistency and availability depending on whatever domain you're working in, and even in different parts of components within the domain. And Kafka allows for all of that. A couple more, my fictitious laser pointer. A couple more configuration items here. I guess not really. Compression's compression. You either compress the data or you don't. Sending the message, this is pretty straightforward. In my simple Kafka producer, I am making the decision that if there's ever an error sending, that I'm just, killing the entire producer. That's my level of if there's a problem, then shut down, right? Go into bunker mode. There's some control you have here with message send max retries, right? So the producer will try 3 times before it actually fails. You may want to make that 10. You may want to make the time it takes a little bit longer. You may want to implement this to not exit or do something differently. It's all open source as part of the sample project that I created. So please feel free to use this Kafka producer as your own template for your own producers. OK, so lots more configurations. So many that it was 3 slides, and I deleted them all because we'd just be sitting here talking about configurations. Go check out the docs. The docs are really awesome. Again, all the configurations are actually in the producer config.scala file. So it's very well commented. It explains exactly what every configuration is doing. I'd say go check that out, and you can see exactly what the configuration is to set how many replicas you want to write to. I think it's request replica ACK or something like that. It doesn't matter. Go look at the configurations, and you can see exactly what they're doing for what you need to. OK, so here's the Akka producer, right? Why would you want to have an Akka producer? OK, so synchronicity is good and important for durability of your data when you need to have very strong, consistent writes. But ultimately, you want to make some decision in your application about how is that actually working. And that actually is a really good use case for Akka. If folks are not familiar with Akka, it's an asynchronous reactive framework that allows you to build pools of actors that are pinned to a core. All right, very, very cool, good stuff when building systems. And in this actor, it's really basically just taking a message and producing it on the producer, right? It's actually just sending a message on the producer, and it's going to send that synchronously. Now, why is that cool? It's cool because The Akka system, if you set up, let's say, 20 actors, right, it still has a mailbox, right? You don't actually have to say that this message has been sent on the queue inside of your application. So if you're doing any type of audit or reconciliation, you can move that audit and reconciliation logic into the actor system. So after the actor system is going to actually just, however many actors there are, let's say there's 20, right? And you're throwing in 1,000 messages per second. If all of a sudden all 20 actors, lose connection to the broker, right? They're all going to sit there, not process any other messages because it's in order, and all 20 are just going to sit and block and wait. If they're successful, at that point, synchronously, you can write back there the auditing aspect of what you've just done, while the rest of your application doesn't have to get bogged down by it, right? So the rest of your application is still running and still processing and doing what it needs to do because it's working asynchronously with the Kafka producer actor. But then still internally within your application, if something goes wrong, you can deal with it, right? You can now make different decisions within your code about how you want to do things. And if something goes right, as it should and continuously does, at that point, you can write your auditing and reconciliation within the actor. So this is a good way to abstract the needs of doing something consistently with trying to be more reactive in your application. It's just another layer of where you can put things. You could also jump into the producer.scala code and update it there. Right? A lot of different ways to solve the same problem. But this is one that I've been working on for a while, and I see it having some good benefits in the community, so I hope folks check it out. All right, any questions? I usually like to ask questions for the end. But if there's anything that's like just so gripping that you just can't wait to the end to ask, you got like 3 seconds? OK, cool. So consumers. All right, so let's talk a little bit more about topics, but let's do it on the partition level. OK? So topics are really a way of organizing partitions. OK? Your broker must hold all of the data for any one topic on the entire broker. So if you only have 2 terabytes of space per broker, then you can't make your topic larger than what would be a 2 terabyte window, right? That's just how it works. On the partition side, you want to break up your partitions in such a way that you can parallelize your consumers, right? Partitions are a way to parallelize and concurrently run your consumers. We'll talk about that a little bit. Read from start, right? So I had mentioned before, do you want to start at the beginning of the stream, or do you want to just pick up at the end of the stream? You have both of those choices. So here's the Kafka consumer as it stands. Now, this Kafka consumer is assumed to be a single thread, right? If you need to have 10 Kafka consumers to actually achieve the concurrency that you need to process a stream, and maybe another 10 to have high availability around that, then now you're looking at 10 partitions, right? You want to have 1 partition for every 1 thread of consumed work that you do, right? Now, I said 10 for redundancy. Well, that's where the group ID comes in. So your group ID is basically how you tell your consumers how to work together, right? So you might have 1 group ID that is the, OK, we're all going to get together, and there's 20 of us, right? There's 10 partitions, but there's 20 of us. And we're all going to work together, and we're going to be maybe a Kafka spout for Storm. Or we're all going to take the data and write it to Cassandra. Or we're going to move the data into Hadoop, or push it to S3, or send it off to Reman, or whatever, right? Consumers are just working together. When you start up all 20 consumers, let's say you start them up on 2 machines, right? Start up 10 on one machine, 10 on the other. Only 10 of those active threads are going to pin to a partition. The other 10 are really there for fault tolerance. So if a machine dies, right, that consumer group of group A, all of the consumers will rebalance to make sure that every single partition is still being streamed from. This is a really important concept when it comes to what you need to do with consumers and how you need to write them, right? You write consumers in a single threaded way, right? The ordering of data that comes into Kafka is done on a partition level, right, at the partition. So you've got to think single threaded. How do I just have this 1 partition and this 1 piece of data, and how do I process it? When you want to make that system multi-threaded, you add partitions. And those partitions then allow you to start multiple threads that read off those partitions and do things concurrently, or in parallel across different machines. You've got to pass in the zookeeper connection. So the Kafka consumers, much like the brokers, which we'll get to in a sec, the Kafka consumers heavily use zookeeper to keep track of where they are in the stream, right? So the scalability that we talked about before and the speed of Kafka, so much of it comes from the broker not having to know where people are reading from it in the stream, right? That is moved to the consumer, right? A lot of scalability comes from that. But in order for it to work, the consumer has to know where did I last read in the stream, and then tell the broker, hey, I last read it, offset 36275. And then the next time it has to come and say, now I want to read 36276, and 7, and 8, and 9, and the rest. So Zookeeper tracks that. Now, the way that Zookeeper tracks that, and let's talk about read from start of stream or not. The way that Zookeeper tracks that is asynchronous, right? As you're reading off of the consumer, right, the high-level consumer, a background thread every 10 milliseconds is writing to Zookeeper saying, oh, this is where I read from, this is where I read from, this is where I read from, every 10 milliseconds. So if the consumer dies, you're going to lose 10 seconds of offsets, right? That's just how it is. You're going to lose 10 seconds of offsets. And for folks, some folks, money folks, for some data sets, like, that doesn't work. Well, I'm going to propose another way that you can use the high-level consumer and still have what you need from a offset committed perspective. You can keep track of the offsets as the Zookeeper connection is running, right? You could just keep track of it. And if you start from the beginning of the stream, every single time you start, then you could just ignore up until where you last stored the offset. Now, since Kafka ultimately is streaming data with very little latency across your network, and if you have 100 megabytes, well, you know what? It's going to take you a second to catch up on everything that was read from the beginning of the stream, right? So you've got to balance, like, how much data is actually in there, right? Do you have like 6 terabytes of data at the beginning of the stream, and it's going to take you hours to read from the beginning? Okay, maybe you should take a look at the low-level API. That's the link. You can go look at the low-level API, right? But if you can sacrifice some time when a consumer comes back online to go through all the offsets and said, did it? Oh, there I am. I haven't done this one yet. Then who cares what's stored in Zookeeper, right? You can then start paying attention to the data that's coming off the stream, knowing where it's been written, right, from your own system, and then do whatever business logic you want to do on it. Eventually, the Zookeeper consumer will catch up, and that's fine. So that's an option. It's one that I hope folks start to look at as an option instead of lots of people trying to rewrite the low-level consumer to do all these different things. We'll see how that goes. All right, so whitelists and blacklists. Bit a little talk about whitelists and blacklists and what's going on there. So you can say, since topics are really dynamic, a lot of companies actually just generate like topics dynamically completely. You may have events dash and then some UUID, okay? And you may have another topic that's purchases dash and a UUID or some hour timestamp or whatever it is. So whitelists and blacklists are basically a way to regex and filter, saying, okay, I want everything that is of type topic tests, right? And really, getting away from having to have, oh, these are the 6,000 topics that I need to look at. I mean, that's a little crazy, right? If you have thousands of topics, you don't want to have to like literally put all of those in. So whitelists and blacklists are kind of a way to, get at all the topics that you want in a single line of code. And what I've done here in the Kafka consumer, hopefully this will let people want to write functional programming a little bit more. This Kafka consumer, except for the configurations, really never has to be touched again. What I'm doing here in the read is I'm actually taking a function in, okay? So the function write is getting passed into the function read, okay? And what that function write is doing is whatever the person wanted to implement when they called the function, okay? What's happening here is when it comes off of the message stream, right, and for message and topic from stream, when it's coming off of the message stream, it calls the function that was passed into it. So if you're using this Kafka consumer, you can implement that function to output to system.out. You could use this function to write to S3. You could write this function to email your mom. I mean, whatever you want to do, you write the function to do that, And you just pass that function into read, and read will go ahead and run that operation. So fundamentally, you never have to write a consumer ever again with this code. All you have to do is just implement the function of how you want to process the message and figure out how you want to parallelize all your consumers, and you never write a consumer again. A lot of this was actually the inspiration for doing these examples because I don't write consumers anymore. I haven't written a consumer in like 2 years. So like I just keep hearing people, oh, I'm writing this new consumer. I'm like, really? OK. So this is a way not to have to write consumers again, configurations aside. All right, so that low-level consumer, all right, you just have to deal and work with the stream yourself. You want to talk to the brokers, go for it. It's really simple to do. There's an application, the simple consumer shell is actually a full-fledged, command line consumer that will do everything you want with a low-level API. So go check it out. I've used it a couple times. It works great. I know there was some talk, and I don't know if it's here. We were talking about how do we reverse the stream and read backwards on the stream, right? Low-level API, perfect for that kind of stuff. All right, so this is my kind of wackadoodle example. Basically, what I said to myself was like, all right, how would I create like a Kafka perpetual machine? So what I did was created a topic and called the topic publisher. All right, so all the publisher data that's going into Kafka is going to be publisher. I have a consumer. The consumer is going to read off of the topic, and I'm going to create a consumer group called loop, and I'm going to throw my broker in here. All of this will work completely out of the box from that example project once you spin up the VMs, right? Because it's just going to go to those IP addresses that's running. We're going to start 2 actors, right? So Akka has the ability to route to your actors in different ways. You can route by who has the smallest mailbox. You can do custom routing. I'm just doing round robin here. So if it's 2, it'll route to A, then to B, then to A, then to B, then to A, then to B. I'm going to loop through this really quick and just throw in the init parameters, just this quick simple way to throw in the init parameters. Back to the consumer side. No, all right, too many slides back. That's all right. And then I'm going to go ahead and I'm going to implement what I was talking about, this define exec, where it's taking in binary objects, right? That binary object that's taking in, this is going to be what's taken from the Kafka stream and given to you in this code, right? And in this code, what I want to do is I want to take this binary object, I'm going to turn it into a string, and I'm going to send it back into a Kafka producer, OK? Just boom, PDC, bang. Message goes right back in. Okay. Now what I'm going to do is I'm going to go and send in 2 messages into the Kafka producer. Right? So this will go to, all right, so just in case, I don't know, this function hasn't been called yet, right? It hasn't been used. This is just a function that I'm just setting up and just waiting on the side. I'm now going to throw in 2 more messages to my Akka Kafka producer. Bang, bang. 2 messages go in. Message goes to A, message goes to B. They both write synchronously to the broker. Okay? And then I'm going to sit and I'm going to block. Consumer.read blocks. Okay? Because it's going to sit there and just read on the stream. It's going to go and it's going to read on the stream. But what happens is that I'm passing in this exec function. This exec function is what is happening inside of that read. So every single time something comes back off of the stream from Kafka, this function gets called. And what does this function do? It puts it right back on the producer, right? So here, what's going to happen is just a loop, right? You're going to take stuff off the stream, and you're going to put it back on the stream. And this is actually kind of useful. I know it sounds a little weird, but this is pretty useful. Why? Because you change that number from 2 to 1,000, and now all of a sudden, setting your messages, you want to make them a megabyte, right? You could really start to get a good sense about the way the system is working and how it's operating and what happens like when you kill a node and what's going to experience with it and who's going to get the Nagios alerts and everything else that you could think about with 6 lines of code. Or, I don't know, I'm not good at simple math. A few lines of code that fit on a PowerPoint. All right, so let's talk about brokers. So brokers, let's kind of finish up the discussion with partitions. Partitions have some good meaning when it comes to brokers. A lot of it is in the load balancing side, which we'll talk about. Talk about load balancing of producers, load balancing of consumers. We'll talk a little bit about replication. I've been using 0.8 for like 2 years now, I think, at this point, almost like a year and a half. I guess I take it for granted that everyone's like, oh, replication just came out. I'm like, whoa, OK. Like I, kind of get lost in where we are in the release cycles. But yeah, replication's been out for a while. Beta 1 came out. Lots of folks ran it in production. A lot of good feedback. All that feedback went into 0.8. So please, try it out. It's good stuff. We'll talk a little bit about the way the in-replica sets work. And then we'll also talk a little bit about the client API and the wire protocol. Just about enough information that'll make your eyes want to bleed. The wire protocol is really awesome. I love it. It's a completely custom-based TCP/IP exchange of byte buffers. If you like that kind of stuff, let's talk afterwards. It's fun. If you are trying to write your own library, you're going to have to like this stuff. Or I'll point you to all the different client libraries and all the different languages that exist today. OK, so partitions make up a topic. This is a pretty standard Kafka diagram that is been around for a while, but I figured I have to have one in there. So this is the anatomy of a topic. As writes are coming in to a topic, it is going to send them to a partition based on how you have decided, to partition that data across the different partitions. So you could have the partitions just hash and modulus. You may want to have it so that all of a specific user is going to go to different partitions. So all of your user data for a specific user is always in the same partitions. Maybe you want to partition things by IP address, right? If you're doing a security system and your consumer is looking at all of the data, and one consumer is specifically trying to figure out whether or not someone is trying to log into the system, well, you know what? IP address may not be good. Maybe you want to do it on username. Because if someone tries to log in with one username at one IP address and another username at another IP address, well, that's not valid. How can the same user be at 2 different IP addresses at once? That would be an alert. But maybe you also want to look at the data by IP address. Maybe you want to see that from the same IP address, 6 different people are trying to log in within the same second. That's probably fraudulent, right? So depending on what topic of data you're sending in, it's very much like, it's like everyone says, you're using Cassandra or HBase or something. You got to think about the query first now, right? Well, this is the same kind of thing. You've got to think about a little bit more, what are you going to do to consume that data? Or just be accepted that when you consume it, you're going to be doing transformations at that time. It's very fast because when writes happen, the cylinder doesn't really have to do anything more than just move up 1 than it just had before. And since Kafka uses Java NIO, there's no user copy. It's all in kernel space. Data comes straight from the socket and goes right to disk. And when it goes into disk, it's going to go into these different partitions. And again, the data in the partition is ordered, but not across partition. Right? So topics will not guarantee ordering. You're only guaranteed ordering within a partition. OK, so partitions do have some more uses that are important. And depending on your scale, you need to think about. If you have 3 brokers, and you have 1 topic, and you have 1 partition, that's probably not a good idea, because you're not going to be able to load balance across your brokers. What Kafka does is it figures out how many partitions there are, and then makes sure that different brokers are the leader for those partitions. So if we have 1 topic, and we have 3 partitions, and we have 3 brokers, then what Kafka will do is it will designate broker 1 to be the leader for partition 1. It'll designate broker 2 to be the leader for partition 2. And broker 3 will be the leader for partition 3. So when the producers are sending data, and it knows that now it needs to send data to 3, it's going to send it to broker 3. Right? So natural effect of load balancing the data that you're producing across all the different brokers. So a lot of scalability comes from that as well, by being able to distribute the load to the different brokers and not just have 1 broker that everything is being written to and the others are slaves. So you can look at this as an active-active system by using partitions to make them active-active, where each partition in of itself, right, is active-slave-slave for whatever other rep was there. Similarly, on the consumer side, you also get some load balancing, right? Here in this example, consumer group A, you can see that we have 2 servers and 4 partitions. Consumer group A and consumer group A can be running on, we could have 2 different servers. So we could have server 1 running C1, which is a consumer in consumer group A, and server 2, which is running C2 and consumer group A. And each of those are going to pull off of two of the different partitions. If one of those fails, then Kafka is going to assign all 4 partitions to that other consumer. Right? So here is another way to accomplish load balancing and scalability, and really where partitions come in. Because here, if you want to have one partition and one consumer, right, consumer group B, you need to set this up accordingly. If you set up 5, 6, 7, 8, none of those are going to get any data unless the first 4 fail. And if the first 4 fail, then Kafka will rebalance and start giving partition data to those other consumers. OK, so how does replication work? So replication is twofold. Okay, replication is how Kafka moves the data to other replicas. And then on the producer side, what are your decisions about, what are your guarantees when you're actually producing the data, which we had talked about, right? Sending the data synchronously, having a number of replicas that are acting. What happens in the background on the broker is if, let's say, server 1 here is the leader for a partition, and it gets some data, and your replication factor is 3, right? It's going to send a write request to server 2, send a write request to server 3, and then wait for responses for an ACK from server 2 and an ACK from server 3. If you set your producer as a synchronous producer, and you say, wait for 2 acknowledgements, then you're going to be sitting and waiting for these round trips to happen. And that might be important and useful in what you want to do, but maybe not. This is going to happen no matter what, right? Whether you produce something and you don't care to get a response back or not, this is the same replication that's going to happen, right? Server 1 gets some information, writes it to 2, 2 will ACK or not. It'll write to 3, 3 will ACK or not. If you want some more information on replication, Shriram was one of the committers. He did a great job at the second user group Kafka meeting, which is streamed. Did a really great job talking about it. June Rao's slides also talk about it. We talk about it afterwards as well. And you really want to get too much into how does Kafka replication work, because there's just so much content out on Google and the internet that you can get. Trying to give some more information and detail and try to get a little closer to the community about what's going on. OK, so the client APIs. So there's a guide to developing with the Kafka protocol. Again, the Kafka protocol is a custom TCP/IP wire protocol. For non-JVM clients, other people have taken it upon themselves to actually go and build libraries that use this protocol. So David Arthur is one of the committers. He maintains the Python library. There's a high-performance C library as well. It has full protocol support. Adobe Labs maintains the C++ library. There's a Go or Golang, however you want to call it, pure Go implementation that now supports Kafka. This is all 0.8 stuff. There's some other things for 0.7. There's a PHP one and a Node and Erlang and what have you. There's also a Ruby library and a Clojure library as well. So even if you don't use Java or Scala, Kafka is very happy to not really care about that, and that's why there's this custom wire protocol. It'll speak to any language that can properly support the protocol and send data back and forth on it. And these are all libraries that have been open sourced and are used by folks.
How does Clojure rate into non-JVM?
So yeah, all right. So it's not so much non-JVM as it is, it's not supported by the Apache project. OK, is that fair? Yeah. So the Apache project only supports the Scala, and then we have some Java wrappers around the Scala APIs, just so that you don't have to deal with $signs and stuff like that. It's kind of weird going from Scala into Java. So there's some Java APIs that wrap that, so you can just call the Java API so it feels more Java-like, I guess. I don't know if I should apologize for that or not, but that's what it is. I mean, I'm glad they're there. I just haven't apologized that people are still using Java. Realized that not everyone understood what I was saying. All right, so again, my name's Joe Stein. I started this company, Big Data Open Source Security. Guess what we do? It's not just security. We do open source projects and client implementations. And trying to figure out and build all of the glue code for hooking together systems like Kafka and Cassandra and Hadoop, and really focus on business domain implementations for companies. I'm on Twitter or email. You guys want to check me out or go talk, or if anyone has questions now, shoot. Sure. Okay, so when you're consuming data, okay, you're consuming data from a topic, but you're doing more than just consuming data from a topic, because what you're really doing is you need to figure out how that data is going to get processed, okay? If you can have a single message coming off the Kafka queue, and let's say that takes a second to process, just takes a second, right? Well, it's going to do that in a single thread, right? So every second, it's going to process a piece of data, right? If you have 1,000 of those, it take 1,000 seconds, right? So, okay, I want to put that in a thread pool, right? I want to make that concurrent, and I want to parallelize it, right? That's the natural effect of what you would do. So the way that you do that in Kafka is you write those to different partitions, right? If you want to have a thread pool, let's say of size 10, so you can do 10 messages at a time, then you would create 10 partitions. Here, you set up the consumer groups in such a way so that you can either read off of the same stream at the same time, or you can read off of the same stream, but with other people participating as well. Okay? So in consumer group A, you have 2 participants. You have 2 consumers, but you have 4 partitions. So Kafka is going to say, all right, I'm going to give you 2 partitions to read off. I'm going to give you 2 partitions to read off. Right? Or in this scenario, where you have 1 consumer for every partition, it's basically like 1 consumer for every partition. And if you had 4 or 5 or 6, or let's say you had consumer group C, right? You need to start to think about the data pipeline as how you're consuming data and what you're doing with it. And that then is a direct result of how you want to set up your partitions, because you need to know how you're going to parallelize that. How are you going to make it concurrent, right? If you have more partitions, more consumers than you have partitions, when some die, it can rebalance and then be able to have it keep going. Something could be wrong in your design. So depending on, and this is something that is different between 0.7 and 0.8, is that in 0.7, if you didn't put in a partition key in 0.7, a null partition key would actually round robin all of your data to multiple partitions. In 0.8, it doesn't do that anymore, right? The assumption is that you have enough producers sending enough data into the system, and the producers will grab onto different leaders, and as a natural effect of data come in, you'll get randomness as far as that goes. If you don't, then what you need to do is start using a partition key. Okay? The partition key could be anything. uuid.randomuid toString, but some partition key. You've got to give it some partition key. If you still find hotspots in your partitions, well, you've got to start to rethink, what are you partitioning on, right? Let's say you partition on an account ID or a publisher ID, and all of a sudden that one publisher just threw 1,000 times X more data, right? And now that partition is getting nailed with 1,000 times more data. Well, maybe your partition key needs to be a little bit more granular, right? If you can't, then you can't, right? You've got to, figure out how to deal with that. Like, so definitely the answer really comes down to what's the data look like, domain-specific use case scenario. But we'll talk about after. Yep. Okay. Yeah, so there's been some talk about that and some write-ups, whether to use ext4, ext3, and how you do that. I'll admit, I've always had good experiences with ext3. I think that if you wanted to use ext4 or XFS or some other file system, that would be OK. There are some controls in Kafka that, from a configuration perspective, can help you reduce that file system caching. So that might be a good place to look as well. I would say, check out the operations docs, shoot an email if need be. Otherwise, go with what you're comfortable with. There hasn't been shown to be a lot of different benefit to using different file systems, at least not yet. Yeah, so that's in there in 0.8. Yeah, so let's go back. I should have actually ended on this slide as well. Boom. Okay, so here are the tools. So they're the replication tools. There are 8 of them, I guess. So you can create new partitions, reassign partitions and replicas, and you could do a lot of functionality when it comes to tooling the brokers and making a lot of changes. I think really the only thing that you can't do yet in 0.8 versus 0.81 is delete partitions. Otherwise, most anything else that you would expect to want to do, you can do in 0.81. Sorry, 0.80. If you want to delete partitions, then you've got to use 0.81. OK. So there's a lot of, besides replication, a lot of bug fixes came out in 0.8 as well. So if you're using 0.7 and it's stable, of course, keep using it, right? Like, why change something in production that's not broken? But if you're going to get into it to begin with, or you're looking to upgrade, there's a migration tool that you can see in the Kafka tools directory that'll help you migrate 0.7 data to 0.8. Right? The wire protocol is completely different and changed. You cannot connect to 0.8 brokers with 0.7 producers and vice versa. The wire protocol was thoughtfully put together so that that won't happen anymore, but it happened now. So my recommendation would be, get up on 0.80. Besides replication, a lot of other fixes and features inside of there. Things like log compaction. I mean, there's so many features that have not even been talked about or discussed that are in Kafka that are really beneficial as you're trying to operate on a day-to-day basis that are in 0.80 that you've just kind of always wanted in 0.7, right? They're there now in 0.8. Yeah, so it doesn't. So there is another project, and I want to say it starts with a W. I can't remember the actual GitHub URL. Every time I see it come in the the Storm user group, I always respond, hey, this one guy got a 0.8 spout working, or what have you. So he has a 0.8 spout working that a bunch of folks I know have used very successfully. As far as the Apache Kafka spout goes, when the proposal for the Storm incubator came about, I totally threw my hand up there and was like, hey, what about the Kafka spout? Right? So the Kafka spout is part of the Apache project for Storm. So I would say now that it's 0.80, it's just waiting for one of you to go in and do the upgrade. I could help if you want, no problem. But it's just a matter of someone going and contributing it in, or using the one I can't remember. Catch me afterwards. I'll try to send it to the Storm list again or tweet it. Off the top of my head, I forget which one it is, but there is one that supports it. Something to fix. If we can get people off of 0.7, then they have to have all the different downside streams that they expect, right? Totally. Another awesome, exciting thing about Storm is now it's part of the Apache project, which is great.
So there's a lot of URLs in these slides. These slides are going to be on the meetup?
They're already online.
Oh,
yeah, so you could either go to my Twitter, which is All Things Hadoop. I tweeted out the link, or I'm Char Malik on SlideShare. If you just Google SlideShare Char Malik or SlideShare Joe Stein or something, it'll come up. It's on my SlideShare. Yep. So Char Malik as in Char Malik. Char Malik.
I have kind of maybe a little bit of a strange question. I think it was Netflix released a doing a project, I think called Suro or something like that.
Maybe.
And I looked at their chart, and they feed Kafka, and Kafka seems like it's doing something.
Yeah.
So I'm like, why?
So,
does it,
yeah. So I'll speak to the second part of that. And the first part, two of the Netflix developers actually spoke at the second user group online. So if you want to see what Netflix was doing 6 months ago with Kafka, just get it from their mouth. But as far as the queuing system goes, really think of Kafka not as a queuing system or not as a message brokering system, but truly as a commit log, okay? It is the journal for all of the events that happen within your infrastructure, okay? LinkedIn sends 60 billion events every day into Kafka clusters, okay? That's pretty good. And what they get out of it is a journal, a commit log of everything that happened, ordered in time, and ordered in a way that they can then consume it. And then they could scale the consumers to consume things continuously, right? They could have batch jobs that go in and replay the entire day. They could have 6 different streams that sit there and watch the data and transform it into any type of OLAP queue that all their customers want, right? That's really the benefits that Kafka brings. And it's important to think of it as a centralized commit log with messaging features. Yep. I have not. When it was first announced, I went to go look for it, and it did that, like, it wasn't actually there, and they had some other data flow pipeline product, and I got really upset about it. But I've heard good things about it. You know, I've heard that it actually uses some of the same patterns that Kafka uses, which is great. You know, I think that, you know, the more systems that are out there that do similar things, we get to understand, you know, what are the trade-offs that we're making. Like for me, solutions are about not just solving problems, but deciding on what trade-offs we want to like deal with, either as individuals or as organizations. So having a service-based system that does similar things, I think, is awesome. Have not played with it. For me, I'd rather just take some Kafka brokers and throw them in EC2 if I was going to do that, but that's just me. Anybody else? Yeah? Every single message has to come through. So on the broker, on the producer side, you want to do a synchronous producer, right? Obviously. And you want to have your replica sets be whatever your tolerance is for data loss to a specific broker. So let's say your requirement is, OK, as long as 2 racks have the data, I'm good. Okay? So maybe setting up 3 brokers, 1 in each rack with replication of 3, and having the sync be you know, a replica of 2, you can lose 1 node, right? That may be a good way to go about it. Could be. On the consumer side, really you're just spinning up consumers and letting the rebalancer take control, right? It doesn't matter if you have 1 topic and 1 partition or 60 topics and 60,000 partitions. That's a development decision that you have to make when figuring out how to consume the data and process it, not one from availability, if that makes sense. I mean, you can do everything with 1 topic and 1 partition. Right? Like I've actually done that. Right? I pushed hundreds of millions of pieces of data through a topic and partition on 0.7, and it works great. It works great on 0.8. Right? But it comes down to like, what are you doing with that data? Right? If you're just writing it to Cassandra, that's going to go really fast. Okay? If you're writing it to Oracle, you might have to have 60,000 partitions to parallelize that. I don't know. But I promise not to Oracle bash. I'm sorry. I guess I'll have to wait to Larry Ellison to come up and catch me somewhere and say something. All right. Any other questions? I'll be here all evening. All right. Well, thank you, everybody.